presentation, a configurable ECAD library solution for all users. If you'd like to join us here at the Exhibitor Forum, we'll be starting in about just 1 minute.
All right, so hello everyone. My name is Julie Liu. I'm from PalPilot for Brinko AI. We provide the customizable ECAD library solutions. And this year, we're using AI and automation to build a configurable ECAD library creation platform called footprintcoolai.com. And today's topic is about a configurable ECAD library solution for all users. All right, so let's first talk about our industry snapshot. So it's how engineers create ECAD library today. It's that the component suppliers provide the datasheets in PDF formats, and this spec describe all the properties, mechanical properties, electrical properties of components, and then engineers will need to manually read and interpret those datasheets and create schematic symbols, footprints, or 3D models. And because different manufacturers, they may have different limitations or capacities, so there are usually a set of guidelines, or what we call design for manufacturing rules. So by implementing these rules early on in the library stage, it can avoid the defects or avoid delays later on during the manufacturing process. That's why engineers also need to consider those DFM rules and make the customizations in the library files in order for them to be production ready. However, so creating the libraries manually and implementing those DFM rules is a manual process, and it's time consuming and also prone to error, right? So as of this year, there are more than 83 million datasheets out there. And every year, there's around 9 million parts, new parts released. So apparently, the manual process of creating the ECAD libraries and implementing the DFM rules cannot just match up to this speed. That's why we need automated library generation process. And this process needs to not only automatically generate libraries that exactly the same as the spec datasheets, but it also needs to be able to give the engineers the flexibility to customize the libraries in order to build in those DFM rules early on at the stage. So our solution starts by data capturing. We have developed this robust capturing system that can analyze and interpret all the information from the spec datasheets. So it's a very complex work, in order to train a system to understand the millions of data sheets and be able to interpret the components information and extract those data, right? So we have been training our system over 1 million data sheets, and the training process is guided by our deep domain knowledges of design and ECAD library creations. So in the end, this capture system are able to extract the information for components, including the basic information, such as the manufacturer's name, part name, obviously, and also it can extract the symbol information from all kinds of ball map, the form, etc. But most importantly, it can read the diagram, the outlines, land pattern, for example, for footprints, which is important for creating a footprint later on. And lastly, it can also extract all kinds of electrical properties from data sheets. So the goal here is to use this AI and automation technology to replace the manual interpreting process of reading the data sheets. All right, and I also want to introduce you our configurable DFM library creation engine. Because we don't just want to build libraries that are exactly the same as a spec, as a generic libraries. We also want to give the engineer the flexibility to input their requirements or their DFM rules and be able to customize those libraries. So this DFM-driven library creation engine can flexibly set up DFM rules, allow everyone to input their requirements, and essentially, so everyone can create their own library generation engine online. And this engine will be able to take any requirements and generate libraries with their rule embedded, so the libraries will be production ready. And lastly, we designed this structured interface as intuitive and as simple as possible so that engineers, when using this platform and interact with the interface, it feels like interacting with a human. So let's use an example to explain how this rule-driven library creation works. So for example, we are designing the land pattern, right? So it's kind of straightforward if you just want to follow the IPC standard or follow the vendor recommended land pattern from the spec. However, so most of the time, engineers may want to, for example, add certain extensions at toe heel of the pads in order to, for more reliable soldering or mechanical support, etc. Or often engineers may want to implement a calculation method based on different package types. This is when we need to give more precise control of the parameters to engineers. All right, so for example, for the J lead or Gawain leads, so normally when we design the land patterns, we want to add toe extension and heel extension for the proper soldering. And heel extension is for the mechanical support, right? So on the left-hand side is a DFM rule that the user want to follow. And in this rule, the user may want to specify how much extension they want to add at the toe and heel positions. And they also specify the solder mass should be 1:1 with the copper. So instead of manually add extension at the pads for every footprint, we can use this DFM-driven engine to just set up the extension parameters, and then this extension will be applied to all these type of leads when creating their pad land patterns. And so you no longer need to manually make the customization for every footprint. All right, and here's another example, which is when we designing the BJ land patterns. So for the BJ with the collapsible solder balls, we usually want to decrease the pad size slightly, and especially for the smaller ball diameters. We want to decrease the pad size, but not decrease too much, because when the ball is small, it may have the risk to not form a joint properly during the soldering process, right? So on the upper left hand is our spec from the datasheet. And of course, the datasheet may provide a vendor recommended length pattern, like in the upper left diagram. If we follow exactly based on the spec, then we will create a generic libraries. But that libraries may not be used directly in the design because engineers want to follow certain DFM rules in order for the soldering to process correctly. And later on, they don't need to adjust design or cause any delays, right? So on the bottom left is a set of rules. Well, this customer may want to reduce at a certain percentage of the pad size depending on the ball diameters. That's why they specify how much percentage to reduce in this table. So the old traditional way of creating a length pattern for the BGA is that engineers will need to check this table and then customize the library files based on this reduction percentage by hand, right? So now we have the DFM rule-driven library creation engine. What we need to do is to just specify a range as shown in the right-hand side panel, a range of the ball diameters, and we set the matching pad size. So once you've configured this right, then this engine will apply the same rule to all these applicable BGA length patterns when it's encountered similar parts. So that's why we're able to scale the production of the library files that are both accurate and being customized to your specific DFM requirements. All right, so in practice, in the real world, the DFM knowledge can be much more complex than the previous two examples. That's why it's important that we have a universal and a scalable data structure that can fully describe the information of the components. This including the full description of the geometry information, parametric information, electrical property, etc. But more importantly, this data structure needs to support all kinds of DFM extension, meaning that the data structure can describe the DFM such as solder mask and silk screen clearance, keep out, and many more, right? And then it can be scalable, meaning that everyone who need to add a new DFM rules or extend their DFM extensions can add their DFM to this data structure without break the pipelines. And lastly, we designed this data structure in order to it to be, can be exported to different EDA formats. So in the end, people are using this DFM-driven library creation engine, generate a library file, and it can be exported to different EDA formats. So they can directly use the library file from their own design tools. And by exporting, the data format can still maintain all these DFM informations. All right, so with that said, I want to show you a small video that brings all this process to life. It shows our vision of how to create the ECAD libraries in the future and how we see it may connect many segments in the industry in the future. Okay. All right, so before I show the videos, and here's the takeaway. So we basically summarize the keys for a DFM-driven, customizable ECAD library solutions. Right, the first is we need to have an AI engine that can accurately recognize all the information from spec datasheets and transfer the datasheet into a machine-readable data format. And we also need to have this configurable DFM engine with a user interface where everyone can easily input their requirement and set up their own DFM guidelines online. So essentially, they create their own engine and that can build the libraries for their needs. And lastly, on the back end, we have developed a universal data structure that can work with all kinds of DFM extensions and can be exported into different EDA formats. All right, so I'm going to play that videos and show our vision of the future library creation.
Building a library manually is slow and prone to mistakes. Introducing FootprintCoo AI, the world's first DFM-driven library platform. Lets you set up your DFM rules and generate library files that meet your design needs. Just simply set up your DFM parameters. Get your ECAD library with DFM built in seconds. Choose your rules and select your preferred EDA format. Then download the library files with your DFM rules built in. Let us build ECAD libraries so you can focus on more creative tasks. FootprintCoo AI connects component suppliers, distributors, and product design companies. Like how Google Maps digitalized paper maps. FootprintCoo AI creates a digital ecosystem using component data, DFM data, to shape the future of the electronics industry.
All right, so here's my short presentations. Feel free to ask me any questions. We also have a booth just on the exit of this exhibiting floor run on the first booth on your on your right-hand side. Yeah, feel free. I'll be there and answer you any questions. Thank you.